Each protein has a specific molecular weight. This property is used by scientists to separate them based on their sizes. SDS page is a technique used to separate proteins using an electric current solely based on their sizes, that is by their molecular weight. This separation occurs through a technique involving electrophoresis, and it is run on a polyacrylamide gel. To better understanding, let's take a look a little closer at each of these terms. SDS is stand for sodium dodecyl sulfate. Meanwhile, PAGE is an abbreviation of polyacrylamide gel electrophoresis, and this is where we get a combined term SDS PAGE. Next, electrophoresis is a procedure that relies on an electric current to separate macromolecules, specifically in this case, protein in a mixture. The separation here is based on the protein's molecular weight. Therefore, SDS PAGE is a technique widely used in forensics, genetics, biotechnology, and molecular biology to separate the protein molecule based on their electrophoretic mobility. The mobility of a molecule through electric fields depends on several factors, such as electric field strength, net charge of molecule, size and shape of molecules, and properties of matrix. So, in principle, SDS PAGE, electrically charged particles or molecules in electrolyte medium migrate to the electrode with the opposite signs when the electric field is applied in vertical SDS PAGE system. When the protein samples are landed onto the well, the protein will be stacking in stacking gel before entering the resolving gel. And when the electric field is applied, the protein is begin to migrate from negative terminal to positive terminal. And at the same time as the sample migration direction shown in this figure, then the protein will be separated according to the molecular weight in the resolving gel by presented with mass. In this case, the particles or molecules flow at different rates depending on the molecular weights protein and charge of the protein samples. Larger molecular weights protein tend to move slowly through the gel matrix, and small molecular weight protein tend to move rapidly through the matrix because they experience less resistance at the time of electrophoresis. As a result, the nearer protein band to the well, the larger the molecular weight size of the protein molecules.
Okay, so now I will explain how SDS PAGE works. First, for the sample preparation, protein need to separate based on molecular weights. To separate protein in an electrical field based on their molecular weights only, we need to destroy the tertiary structure by reducing the protein to a linear molecule. SDS is a detergent that is present in the SDS PAGE sample buffer along with the reducing agent like beta-mercaptoethanol to break down the protein disulfide bond. It will disrupt the tertiary structure of the protein. This brings the folded protein down to the linear structure. SDS also coat the protein with the uniform negatively charged. SDS bind fairly uniformly to the linear protein, means that the charge of the protein is now approximately proportional to its molecular weights. Second is the gel matrix preparation. To separate protein inside the sample, a gel is needed. This polyacrylamide gel can be divided into two layers. On top is known as a stacking gel. It concentrates all protein in one band. Below is known as a separating gel. It allows protein separation according to their molecular weights. The gel is inserted into the chamber and everything will be filled up with the buffer solution. Then the protein sample will be pipetted into the well and the electrodes are connected to the power supply. Next is gel running. When the electric is applied, the negatively charged protein will run through past the gel. The protein will travel from cathode to anode. Large protein will travel slower compared to the smaller protein, which will travel faster in the separating gel. In order to see the bend in the separating gel, the gel needs to be stained first. Therefore, one can use commassive blue. It is a dye which can visualize protein. After the commassive staining, the different protein bands are revealed. Lastly, when we want to identify or confirm the presence of the specific protein, The gel can be used in the Western blotting analysis.
So the next one, I will explain to you about the application of STS page. So the STS page in combination with protein stain is widely used in biochemistry for the quick and exact separation and subsequent analysis of proteins. It has comparatively low instrument and reagent cost, and it is an easy to use method. Because of its low scalability, it is mostly used for analytical purpose and less for preparative purpose, especially when largest amount of protein are to be isolated. Additionally, SDS page is used with the combination of Western blot for the determination of the presence of a specific protein in a mixture for proteins, or for the analysis of post-translational modifications. Post-translational modifications of protein can lead into a different relative mobility, that is a band shift, or to a change in the binding of the detection antibody used. In the Western blot, there is a band disappears or appears. However, in mass spectrometry of proteins, SDS page is widely used method for sample preparation prior to spectrometry, mostly used in gel digestion. In regards to determining the molecular mass of a protein, the SDS page is more exact than an analytical ultracentrifugation, but less exact than a mass spectrometry. Lastly, in medical diagnostics, SDS page is used as part of HIV test and to evaluate proteinuria. In the HIV test, HIV proteins are separated by SDS page and subsequently detected by Western blot with HIV-specific antibodies of the patient if they are present in the blood serum. SDS page for proteinuria evaluates the levels of various serum proteins in the urine, that is albumin, alpha-2 macroglobulin, and IgG. So thank you, that's all from me.